Hello, welcome to my channel, and in this episode I'm discussing Rutherford Atomic Model. Ernest Rutherford, when carried out alpha scattering experiment, opened a new dimension for the atomic theory. So on the other side of the video, let's meet to discuss the Rutherford Atomic Model and what were the outcomes of Rutherford Atomic Model and how it transformed the atomic theory. Welcome back. Now, before Rutherford proposed his atomic model in 1911, before that, Thomson has already proposed an atomic model which was termed as plum pudding model. You can see on the screen. Now, according to plum pudding model, it was positive charge was distributed over the sphere and negative charge was randomly arranged, or it was scatteredly present in the sphere to nullify the positive charge. Now, to confirm this atomic model, Rutherford tried some experiment. On your screen there are the findings of J.J. Thomson's atomic model. You can jot it down or you can take a snapshot of it. So this was the apparatus set up by Rutherford in his lab. This is the lid chamber, and in this lid chamber a radioactive substance, rubidium bromide. So rubidium bromide was placed, and which was an alpha emitter. So alpha particles were emitted out from this radioactive substance. Now what are alpha particles? Alpha particles are the radioactive disintegrations of an atom in which the charge on the particle is +2 and the mass of the particle is 4. So it is often regarded as helium nuclei. So these alpha particles were made incident on the gold foil, and which the gold foil was basically surrounded by the zinc sulfide. So when alpha particles were made incident, Rutherford thought that majority of alpha particles would be repelled back, because now according to plum pudding model, all positive charge was distributed over the sphere. So positive charge was over the sphere and negative charge was scatteredly or randomly arranged. So now when alpha particle would approach towards this positively charged species, so it would be repelled back because there would be repulsion between two like poles. So he expected that majority of alpha particles would be repelled back. Only few alpha particles would pass through the gold foil and would hit on this zinc sulfide coating to give scintillations. But when he carried out the experiment, the results were totally different. The results obtained of this experiment was, first was 99% alpha particles went straight through, the gold foil. Second conclusion was some particles were deviated at an angle. And the third conclusion of the experiment was only very few particles, 1 in 20,000, were repelled back. On your screen, there are the conclusions drawn by Rutherford from the experimental results. You can jot it down or you can take a snapshot of it. Based on these experimental results, Rutherford concluded that all positive charge was not distributed over the sphere, but it was concentrated at a point he termed as nucleus. Now, the reason for concluding this was, if this is an atom and majority alpha particles are crossing this atom, then the nucleus which is positively charged should be very small in size, and positive charge should be present at a point, so then only the alpha particles would be passing through the atom. So this was the first conclusion of his experiment. Now the second conclusion was that volume of nucleus is negligible as compared to volume of atom. Now diameter of nucleus is 1 Fermi meter, or which is 1 into 10 raised to power minus 15 meters, while for atom the diameter would be 1 angstrom, which is 10 raised to power minus 10 meters. So diameter of nucleus is to diameter of atom. If you take the ratio, so it would be 10 raised to power minus 15 over 10 raised to power minus 10. So therefore diameter of nucleus would be 10 raised to power minus 5 times diameter of atom. So practically speaking, diameter of nucleus is 1 lakh times smaller than diameter of atom. So this was the reason Rutherford proposed that volume of nucleus is negligible as compared to volume of atom. Now his third conclusion was electrons revolve around nucleus in fixed planetary orbits. So he proposed that if this is nucleus, then electrons are revolving around nucleus in fixed planetary orbits. So now he suggested that electrons are not randomly arranged, they are revolving around nucleus in fixed planetary orbit. And this was the drawback of Rutherford atomic model, because when he was asked that how these electrons are stable in an orbit. Now if I elaborate this, say this is nucleus and this is an orbit of say I am considering hydrogen atom. So this is one proton and this is one electron which is revolving around nucleus. Now mass of proton is 1.67 into 10 raised to power minus 27 kg, and that of electron, mass of electron would be 9.11 into 10 raised to power minus 31 kg. So practically speaking, proton is roughly 10,000 times heavier than electron. So because between proton and electron there would be electrostatic attraction, so electron would be dragged inside because of the electrostatic attraction. When he was asked that how electron is stable in this orbit, he was unable to explain this stability of electron in the orbit, and this was the major drawback of Rutherford atomic model. So on your screen there are the findings of Rutherford experiment, so you can jot it down or take a snapshot of it. So this was all about Rutherford atomic model. If you want to stay connected with us, then you can follow us on Facebook, Instagram and Twitter. If you haven't subscribed to the channel, then do consider subscribing the channel and don't forget to hit the bell icon to get an instant notification. As a student, it's an urge to attempt as many as questions possible and to face the tests, as many tests are possible. So if you have such an urge, then you can subscribe to the link that is on the top of your screen. And thanks for watching the video.